Assalamualaikum warahmatullahi wabarakatuh. We are from Green Group and today we will be presentation our mini project Taguchi experiment for paper plant. For our group member Naufal Erwizal bin Rizalma, Muhammad Faiz Hadi bin Edi Azami, Muhammad Azhar bin Azhari, Ahmad Muslim bin Sulaiman, and the last, Nur Halimi bin Norisha. In this presentation, we will explain how we apply the Taguchi method to identify the best paper airplane design and optimize its flight performance. Before we begin, here is an overview of today's presentation. First, we will introduce the background of the project in the introduction session. Next, we will explain the objective of the experiment. Then, we will describe the methodology, including the experiment, procedure, and the factor involved. After that, we will present and discuss our result. Finally, we will conclude the presentation by summarizing our finding and the effectiveness of the Taguchi method in optimizing paper airplane performance.
Assalamualaikum and good morning. My name is Nur Halimi bin Norisha. My matrix number is 251353347. And for today, I want to tell about the introduction of this experiment. This experiment utilized the Taguchi technique to optimize paper airplane flight by analyzing the cause and effect dynamics between paper weight, launch height, and specific design configuration to achieve the longest and most stable autonomous flight. Conducted to provide empirical research data for instructor review and demonstrate the method's practical application in error-prone real-world fields like structural engineering. The study carefully measures the maximum linear distance traveled in meters using a digital device, while acknowledging the influence of uncontrollable noise variables such as varying landing surfaces. The primary objective is to identify the most aerodynamically efficient wing design that maximize flight distance. Classifying models with the shortest flight as aerodynamic failures. Ultimately, this control study aims to validate the Taguchi method's effectiveness for design optimization in fluctuating environments while uncovering key insight into the variables that dictate paper airplane performance. For the next part is the objective. First objective is to choose the best 3 paper airplane designs from the 15 total designs we tested. Number 2, to see which design can fly the furthest so we can find the best one based on how far it goes. And the third objective is to use the Taguchi method to find the best combination of factors and make the final airplane design much better.
Okay, so in this slide I will explain the Taguchi orthogonal array that we use in our experiment. The Taguchi orthogonal array helps us reduce the number of experiments while still obtaining reliable results. In our projects, we use 3 control factors which are design, paper weight, and launch height with 3 levels for each factor. Instead of conducting 27 experiments, we use the L9 orthogonal array, so we only needed 9 experiments. This helps us save time and make the experiment more efficient. Okay, in this slide I will explain the control factors and noise factors used in our experiment. So we use 3 control factors which are design, paper weight of 60, 70 and 80 GSM, and launch height of 100, 150 and 200 centimeters. So we also use 2 noise factor which are the landing surface and the person throwing the airplane. These factors help us identify the best combination for achieving a longer and more consistent flight distance.
Assalamualaikum. My name is Muhammad Azhar bin Azhari. My matrix number is 251353337. Today I want to present about the methodology of front experiment. First is methodology. Firstly is systematic review. Evaluated multiple directions to streamline the design selection process. Number 2 is final selection. Narrow the choices to 3 distant paper airplane models. Number 3 is targeted testing. Choose this specific design to accurately measure the experiment's control and noise factor. Next, my presentation is run experiment. The experiment tested the flight distance of paper airplane using a structure method across different environments. Step 1. The variable and testing environments were established. Student 1 Far East record the design A, B, or C. Paper weight is 60 GSM, 70 GSM, or 80 GSM. Service type, smooth at Dewan Kuliah Unimat or road at the car parking area. And the assigned role, student 2 Alim or student 3 Azhar. Step 2. The starting height for the throw was measured. Student 5 must use a measure tape to mark the design dropping height 100 cm, 150 cm, or 200 cm. Step 3. The selected paper airplane was carefully thrown from the measured height. Alim or Azhar executed the throw according to established experimental sequence. Step 4. The landing distance of the paper airplane was measured. Student 4, Nofar, used a digital meter to accurately record the maximum linear flight distance. Step 5. As the experiment was repeated systematically, each airplane was thrown 3 times to calculate the average flight distance. This process was repeated for all combination of weight, design, heights, throwers, and surface. Switching to the row surface states, as outlined in the experiment result list, this procedure details how the group conduct the paper airplanes experiment to analyze flight performance. All gathered data was subsequently recorded into the table 6 of the data table for accurate comparison.
Assalamualaikum warahmatullahi. My name is Nopal Bezan, matrix number 2313536661, and for my part we are explaining about result. So we have 9 total experimental runs. We make it based on design, weight, and height. For design A, we do it 3 times with the height 100, 150, and 200, and the weight is 60, 70, and 80. And for design B, we do the same, but we change the height of organization first to 100, 150, and 100. And the weight is also 60, 70, 80. And for design C, we also reorganize the height structure, which is the first one is 200, and then 100, and lastly 150. So make it total for 9 experimental runs. And for A, smooth surface, and the distance for experiment 1 is 10.89, and the second one is 8.56, and the third one is 7.5, and the average we got it from calculation for 8.85, and the distance also was calculated. We add all the 3 and then divide by the 3. We got 6.49667. And then for the smooth and rough, we do it based on the noise factor. And after that, we got the mean, sum, using, and then we got based on the calculation, we got the signal to noise ratio (SNR). So as you can see, we do it for all 9 experimental runs. We got the average for smooth and rough, noise factor, and then we got the mean sum square, and then we got the signal to noise ratio (SNR) for all 9 experimental runs. So this is all for this part result. And then for the next slide, we will explain about the conclusion. So for the next part, this conclusion, the Taguchi method was successfully employed to optimize the paper airplane design and flight performance by systematically evaluating critical parameters such as paper type, wing configuration, folding position, and launch angle by utilizing an orthogonal array of alongside a signal to noise ratio analysis. The experiment pinpointed the ideal combination and of variables required to maximize both flight and distance and aerodynamic stability. Operating as the core analytical framework, the SN ratio analysis effectively accounted for fluctuating noise factor, including ambient air current, minor inconsistency in folding technique, by calculating the SN ratio for each control variable and potentially integrating analysis of variance ANOVA. The study aimed to isolate the parameters more critical to flight success. So by that, ultimately, this systematic balancing of controllable design element against uncontrollable environmental noise reveal the ultimate paper airplane configuration. The precise combination of design, paper size, and launch angle is necessary to achieve the maximum possible distance and airtime. So that is all from our group Hijau. So, and thank you for giving attention for our presentation. And once again, thank you.